All right, welcome back to Demon Programming. In this video, we're going to go over uh, the enumeration data type, and we're going to build a little email validator that we're going to ultimately use in our server. So thanks for watching, and I hope you enjoy the video. All right, in this section, what we're going to talk about is some data structures and how they work in Rust and some things we can do with serializing them. And in future lessons, we will be using the file system to save those serialized data pieces to files. At some point, we may incorporate a database into this, but for the moment, we want to get some things set up so that we can we can save information about the game. So the first thing that we're going to do is go in here to the cargo.toml file and add in some dependencies. Let me move some things around here. So one of the things we're going to be working with is Serialization and Serti, which is serialization deserialization package. This is crates.io. I don't recall if I showed this to you before, but crates.io, you can look up a whole variety of crates. There are literally millions of crates on here for doing different things. Some are good, some are really bad, so you kind of got to look into them and really, the ones that are used by the community a lot, like Serti and Serialization, are really good. So what we're going to do to bring this in, and there's some other packages we'll be bringing in as well, but for the moment we'll bring in the serialization and deserialization package. So we're going to put these here. So this is the way you identify a package. This is cargo.toml. It's in our Rusty Common library folder. This will tell it that it depends upon on these, and it'll actually pull the packages from crates.io. So if we do a build now, you can see that. We'll just do cargo build. And hopefully everything builds okay, but it's going to come up down here with pulling those packages in, and then we'll have access to them. And then I'll show you how we're gonna arrange our libraries. And every once in a while, this takes a little bit of time, depending on how many packages it needs to pull. There it goes. 1 second here. Pull this back up. So there it is. It pulled in Serti and Serialization into Rust Common. So here's our main library file. I'm going to get this this test out of here, because in this, what we're going to do is we're going to create some modules underneath this Rusty Mud Common crate. And the way we're going to do that is just with files. And we're going to call this one player.rs. And so it's in this player RS module that we are going to define everything about the players that are going to be connecting to our server. So in order to access this, we want to come in here and go pub mod player. And now we've got this player module. Okay. Let me bring up a, oh, I've got it over here. Okay. So what we want to do is think in terms of what a player is. So we're going to need several more packages to do this. So let me pull those in. We're going to need, I'll explain what these what these are as we go through them and start using them, but here's some more packages that we're going to need. So this is for regular expressions. This is for hashing passwords. This one we'll use later. It's for our configuration system. It's YAML for Rust. Directories is an external package that gives us a platform-independent way of accessing common directories like the players or users' home directory and their data directory, this sort of thing. And this ZXCVBN is a protocol for analyzing passwords and password strength that we're going to use for the user password. So let's go over here to player. And let me pull it up here so that I have my notes available to me. All right. So the first thing we're going to want to do inside this module is bring these packages that we're going to ultimately use into scope. So the use statement brings these pieces into scope within our module. All right. And now what we want to think about is what we want from a user. Okay. So we want to create a player account, and a player account is going to have an identifier. I thought about using a GUID or a UUID, but I just decided to do with an integer ID. We need an email and a password. Well, so I want to control, however, what an email is and what a password is in a very specific way. So that's where we're going to talk about designing with data, or domain-driven design, figuring out what your data is going to look like, and also controlling the data. So let's think about it this way. An email address can be just a string. Well, the problem with a string is that you can do anything with it. You could pass a password into something that expects a username because it's a string, okay? By wrapping strings and other basic data types in custom types, we prevent the possibility of passing that thing into the wrong function because it becomes a very specific type. And in this case, what we're going to talk about is our email type, which is going to be an enumeration. So to create an enumeration, we're going to go pub enum this. Now, the nice thing about Rust is they have these, we need a name, email, okay? So this is going to be an email address. It's going to be a container for an email address. And the nice thing about this is wherever we pass email type, we can only accept an email type, so we know what it is. But we can also, with enumerations, create subparts within it, enumerations within it that hold specific data. So when we first receive a password or a email, we're going to call it raw, and we're going to have it be a string. Okay, so this is a little different than an enumeration in C++ or C#. This comes from the functional programming world, where enumeration types can contain other data and other data types. And so we want also to be able to validate that email, and that one will hold a string. Our email address. We want to be able to verify our email address, and then we want to know if it is for some reason invalid. And this will take a string and another string. It's going to still hold the email address that was passed in, but it's going to have some error message as to why it's invalid, or we can eliminate that and have our functions return a result, which, let me see if that's what we do here. I did several different ways of looking at that. Yeah, we're going to use the result mechanism. So there's our email address. Now we can also implement functions on this email address. Just like in kind of, as an object, we can have functions associated with it, and we can have functions that are attached to it but not associated with it. Okay, so we do this by saying implement email, and this is the implementation block for this type, and it allows us to create functions within here. So the first one we're going to create is a function called new that takes in an email as a string and returns self. Self is with a capital S is a keyword that allows us from within an implementation block to just not have to type this name over and over again. It's synonymous with email in this case. Okay. So now what we want to do is create a regular expression. And if you're not familiar with regular expressions, there's lots of tutorials on them out there. This particular one is a regular expression that does basic email addresses in a reasonable way. It doesn't cover every possible type of email address, but it'll cover the ones that are commonly used by people, which is all we really care about. There are some special characters and other things that can go on with emails, and these regular expressions for validating an email can become very involved. But this simple one will get us through the majority of email addresses. And if somebody's email address fails this test, well, I suppose that's in a way just too bad. They've got some weird email address. So now we've got this email address, and the way you identify or determine what one of these you're dealing with is oh no, we don't have to do that here. I'm sorry, I put this in the wrong place. All we're going to do in this one here is return email. I think we can use self here. Yeah, raw, and pass in the email. So the new function will just return this raw type as an email. So we know that this has not been validated in any way. It's just a raw email address. Now we want a function to validate it. Pub fn validate. Now this one up here is a non-associated function, meaning that it isn't associated with a particular instance of this. It's associated with the type itself because we're not passing in self. But if we pass in self into here, this becomes an associated function, and we're going to return an email. Actually, we can return self, and now we're going to use that regex, because now we're going to validate that the email is a valid email. Okay, so we're calling this on an instance of this that actually contains an email address of some kind. And the only thing we're interested when we're validating it is if it's raw. That's the only one. So what we're going to do is match on self, which is this value passed in here. And we're going to check for email raw, and this is called pattern matching, by the way. And this is a placeholder. So this, when this matches email raw, the pattern match will assign the email address that's stored in that to this variable. I just call it em for short. Okay, and then what we do is we put one of these, and we're going to do several. We're going to do something a little different here, so I'm going to put these around it. You don't have to have these. The other thing that we're going to look for is anything else, in which case we're just going to return self. It's already validated, or it's been determined to be invalid. It's already in one of these categories. Validate's not going to do anything. It's just going to return it. It's already whatever it was, it is. Okay, so inside here, we don't actually need these, so I'm going to take those out. In here, I'm going to call match, and we're going to call this email regex dot is match ampersand em. Now, why is it ampersand em? This expects a string. And now we can put these. This expects what's called a string fragment, or a reference to a string, whereas what we've got in here is an actual string, so we put the ampersand to pass that. Now if this comes back true, the match is on true, we're going to go email, we're going to go self. We can actually, we can technically use self here too. It doesn't matter. Self : validated. Did I type it wrong up here? Yes, I want to have a D after it. Validated EM. So if it comes back true, we're going to return validated with the email in it. If it comes back false, we're going to return invalid EM. And that's all there really is to that. So that's going to validate the email, and now we've still got the same type coming back. Why doesn't it like this? Let's try to do a build. Let's see if I did something wrong here. Oh, nope, it built just fine. Okay, oh, and the error's gone away. Sometimes when you do a rebuild on these, the self thing comes back a little bit better. So now we've got validated. The one thing we can't do just yet is the verified, because verified, we're going to have a working server and be able to send an email and be able to receive the token back. But what we can do is put placeholders in place to do the verification. And the way we're going to do that is when we come up with validated, actually what we could do is store a token. Once we validate it, we could store a token in here, a randomly generated number. But I'm not going to worry about that right now. We're going to come back to that later, verifying it. But we're going to have a placeholder function in here. And the placeholder function is going to take a token of some sort. We'll just make it an I32 for the moment. But for purposes of this, need to actually verify token. And we might change that later, but for now what we're going to do is return self : verified. Actually, we've got to get we have to match on it. So what we're going to do is match on self, and only if it's validated, self : validated EM, are we going to return a self : verified EM. Otherwise, we're just going to return self. And later we'll actually go through a little verification step here where we'll check the token that was passed in against some original token that was generated for it, and if the tokens match, then we're going to verify the email, because the only way they can match is the user got the token via the email and put it back into the system in some way. So we'll just leave a we can actually leave a to-do here. So that's that part, validating the email. Now what we can do is just have an overall process. We have those two functions, and you can do them separately. But we can yeah, you know what? We'll just leave them as separate now. I was thinking of chaining them together just to do the new and validate at the same time. Well, why not? Pub fn process email string returns self. And this is very similar to new in that we're going to call email, we're going to call self : new email dot validate, and that's what we're going to return. So process will do it all at once. So let's set up some tests for email. So the way we're going to set up tests is we create a module. So Rust has a built-in testing framework, and we're going to create a module here, mod tests, we're going to call it. And we're going to designate this as a test module with the configuration of test. Oops. So this is a module, a test module that's designated with this will not get built during a normal build, whether it's a debug build or a release build. It'll only get built when you're doing a test build to run the tests. And what we can do is just run cargo test, and it'll run all the tests in our system. So let's create a simple function here. The way you create a test is with the test metadata, the test attribute on here. And then we go function, and we'll say, email returns validated email address. And so let's just say let address equal someone at someplace.com. So that should be a valid email address, and we're going to go to string. So that makes it a string and not a string fragment. If you just put this in quotes, we call that a string fragment. It creates a reference to a string. ToString actually builds it into a string, which means it gets put on the heap and is something that can be, how'd that happen? Okay, so let email equal email. Oh, we got to do it. Come up here and go use superstar is fine. We're just going to bring everything in the upper module here into scope in this one here. Email : process address. So there's a variety of ways that we can do this. So what we're going to do here is a match email, and we're going to match it with email : validated. We don't care about the actual address, and we'll just call assert. Actually, let's do get the address. Call it em address, and let's assert, just to make sure it actually came through, equal address. And then anything else that comes back is a failure. So we're going to go assert bang false, comma, can we add a message? I thought you could add a message on this. Ah, come on. Let me see this. Custom messages. Assert false. Email was not validated. Comma ADDR. Okay. So now we can run this test, and we can even check it by modifying this and see if we get our error message. So let's do cargo test. Something didn't build. Oh. I still get tripped up sometimes by the borrowing rules. Let's just go anything else. Have to check all of them to do that. So let's just take that out and take this out for now. Now I'll see if I can work out something a little bit better for that. Let's run this test. This should work. Assert equal. Okay, well, we're just going to say assert true. We just want assert, not equal. We'll get through it. Here it goes. Okay, it looks like it's going to run the test this time, and the test passed. Okay, so if we just go in here and like take this @ sign out, and we'll make an underscore and run the test, it should fail if our validation thing there, test failed. And what's it say here? Test failed. Player email was not validated. Yes. Actually, we could say email was invalid. So let's put this back to valid, and we're going to make one now that does just the opposite, and make sure that it fails on some bad email. We'll make this invalid. We'll make this an invalid email address, and we'll just we're just going to reverse this around. We'll leave that as anything else, and we'll make this invalid. And now we've got our two tests. Cargo test, And there we go. And we can look up here. Running 2 tests, okay and okay. So both those tests passed. How are we doing on time? Wow, we're already at 30 minutes and we haven't even gotten to passwords yet. So it takes a little bit of time. And why are we getting all of this mess? Unused doc comments. So we did get through enumeration. There's one more type, and I'll talk about that in the next video. We'll talk about structures, and we'll set up the actual user account. We'll finish this up with the password system that takes care of the password, and we'll move on. So we'll do this one stage at a time. So what we covered was a little bit about using regular expressions here, using a regex. Now I'm going to go into the details of how to build a regex. I'm not even all that expert at it. I can usually muddle my way through, but if you're interested in learning a little bit about regexes, I can tell you about them. Just leave a comment below and I'll talk more about regexes, but this is how you use them, and then you can match on them and you can get groups out of them and do all kinds of stuff with them. And we'll be working with regexes in other areas as well. Let me move this comma up here. And so this the code that we wrote today will be available on GitHub. In fact, let's put it up there right now. It's going to be in a branch called Lesson 3. So let's go git add dot git commit -m email validator working, git push origin, and it's lesson 3. So that'll be available on lesson 3, and it will eventually be available on the master branch too. I will be updating the master branch periodically, but you can just go onto GitHub and select that, and I'll show you here. If we just go here, bring this over GitHub. So there's a couple of it's expecting me to do pull requests. You won't see that, don't worry about that. If we come down here and select lesson 3, then all the code that we just did should be in here, right here, player.rs, and there it is. So that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video. Thanks for watching.